Hello class, today we're going to be going through Unit 12, Day 3 notes, arc length, sector length, and radians. To start off, we're going to talk about an arc, and it's just a portion of the circumference of a circle. So it's part of the circumference of the circle, and you'll recall that the circumference of the circle is just all the way around the circle. Okay, so an arc is just part of that right here. An arc length can be calculated using the formula x degrees, so in this picture it's theta, divided by 360 degrees, because that's how many degrees are in the circle, and you multiply it by 2 pi r. So all we're going to do is take that formula and use it on these next couple problems. So for this one, we need to find the length of LM. This is our arc. So our arc is going to be equal to x degrees, so 60 degrees, divided by 360 times 2 pi r, the radius. All you have to do is plug that in your calculator and you get the answer. Without converting pi to a decimal, you end up with the answer 4.33 repeated times pi. So if you want your answer in terms of pi, that's where you would stop. However, we can continue and multiply 4.333 repeated times pi, and we get our arc length is approximately 13.61. Alright, we can do it again. We are finding the length of EF. So see, this is an arc. It's part of a circle. And we're just going to use this formula. X degrees, or 120 in this case, divided by 360 times 2 pi, and r is 6. So if we multiply 120 divided by 360 times 2 times 6, we're left with 4 pi. So that's in terms of pi, but if we actually multiply it out, our arc length is approximately 12.57. And then we can do it again. What is the length of the radius? So this time we are given the arc length and we are trying to find the radius. So it's the same thing, we're using the same formula, we're just solving for something different. So our arc length is 9.6, and that's equal to our equation x degrees, or 50 degrees, right here, divided by 360 times 2 pi. And this time we don't know what r is, so we're going to leave it as a variable. So if I multiply 50 divided by 360 times 2, I'm left with 9.6 is equal to 0.277 repeated pi r. Now I can divide both sides by 0.277 repeated pi to get rid of those numbers and get r by itself. So I get 9.6 divided by 0.2777 times pi, and I'm left with 11.0008 equals r. So approximately 11. R, the radius is approximately 11 if we're rounding to the nearest tenth. Okay, so that's, if we're looking for the arc length, we can do it like this. If we're looking for any of the other variables, we can do it like that. We're just solving for what's missing. Now the next piece is a sector. And a sector is the portion of the circle enclosed by two radius, or two radii, and an arc. So in this picture, we have a sector being closed by a portion of the circle, so this arc right here, and these two radii are enclosing this sector area all right here. right? And we can use a formula to find the area of that sector area. And again, we're just taking numbers and plugging them into the formula, so it's not too complicated. This time, our formula is x degrees divided by 360 degrees times pi r squared. So we're simply finding the area of the shaded region. So the sector area is going to be equal to x degrees, 210 in this case, divided by 360 times pi r, which is 12, squared. And then we can just put that in the calculator. 210 divided by 360 times 12 squared is 84. And then we still have that pi. So if you wanted to leave it in terms of pi right here, that's where you would stop. Or you can continue, multiply it by pi, and you get the sector area is approximately 263.89. That's all there is to it. We can do it again. Area of the shaded sector. So again, we're finding this sector area right here because it's enclosed by a portion of the circle and 2 radii, and simply using that equation. Sector area is equal to x degrees, 45 degrees, divided by 360 times pi r squared, and our radius is 16 this time. And again, you can put it in your calculator. 45 divided by 360 times 16 squared ends up being 32 times pi. And then if you wanted to continue to the next step, multiply it out, and the sector area is approximately equal to 100.53. Again, just like the previous problems, we can also solve for different portions of that equation. It's just basic algebra. So this time we're given the sector area is 28.26, and we need to find the radius. So my sector area is going to be 28.26, and that's equal to x degrees, or 90 degrees, divided by 360 times pi r squared. And since we don't know what r is, we're going to leave it as r. Okay. First things first, we need to get r alone. Okay. So what I'm going to do is simplify this a little bit and divide both sides by just this whole chunk right here. 90 divided by 360 times pi. So when I put this in my calculator, I'm just going to simply put parentheses around this entire thing when I put 28.26 divided by parentheses 90 divided by 360 times pi. And that way, the order of operations is sure to be correct. Okay? So 28.26 divided by parentheses 90 divided by 360 times pi. That way my answer is as exact as possible. And I get 35.97 is equal to r squared. Now I need to still take the square root, because it's still r squared and I want r all by itself. So I'm going to do the square root of 35.98. And I get r, or the radius, is approximately equal to 5.998, or if we're rounding to the whole number, it's approximately 6. Okay? 2 down, 2 to go. Next we're going to learn about radians. A radian is the angle made at the center of a circle by an arc whose length is equal to the radius of the circle. Okay, what does that mean? So 1 radian is actually an angle. So we're talking about an angle, and it's going to be 1 radian that's made right here when you have an arc that is equal to the length of the radius. So if the radius is 5, this arc is 5, then we get 1 radian. Okay, so we're just going to be finding the value of a central angle in radians. Okay, 1 radian is equal to that. So we need to find the central angle right here, theta, calculated in radians. Okay, so what is the radian measure of the central angle? Well, we're given a formula. So the radian angle is going to be equal to the arc length. So right here, this whole arc is 10, divided by the length of the radius, which is 2. So the radian measure is going to equal 5. And that's it. So again, you're going to have these formulas. So as long as you understand what it's asking for and you can plug in those numbers, you should be fine. Okay, so the radian measure is equal to the arc length, which is 6, divided by the radius, which equals 4. One more. The radian measure is equal to the arc length, right here, divided by the radian. The radian measure equals 1.5. Okay, so far we did, arc length with our formula, sector area with our formula, and radians with our formula, radian measures. The last thing we're going to kind of dip into what we went over last class, because circles can also help us solve problems involving regular polygons, which is what we went over last problem. For instance, in this pentagon, we know that each side is 12. So again, all these sides are going to be 12. So before, when we were finding area, we first needed the perimeter. So the perimeter is going to equal to 12 times 5, because there's 5 sides. So we already know that the perimeter equals 60. But what we're missing is the apothem, right? Because the formula for area of a regular polygon is 1/2 times the apothem times the perimeter. Well, we've got the perimeter, but now we need the apothem. So what can we do? Well, I mentioned last class briefly that when you have a polygon inscribed a circle, all of these things are given angle degrees, right? So a circle has 360 degrees in it, so that angle plus this angle plus this angle plus this angle is going to equal 360 degrees. So if you wanted to find the measure of each one of those, you simply do 360 divided by 5, and each one of these is 72 degrees. Okay, we're getting closer to something being helpful to be able to find our apothem. Speaking of which, our apothem is that line that goes from the center to the center and creates a 90 degree. Well, as you can see here, I'm starting to have a right triangle forming with my apothem and the radius. Okay. Because I know that all the sides are 12, just like last class, I can say that this side right here on the outer edge is 6 because the apothem goes halfway. So now I know this side is 6. I'm looking for the apothem. The one other thing I know is the angles, because this entire angle is 72, which means that this little piece is just half of 72. So this piece is 36 degrees. So if I were to take this little triangle and draw it outside of my polygon, this one that we're working on over there, I've got my right angle, I've got this angle is 36 degrees, this is my apothem, and this is 6. This suddenly looks like a problem that we did last unit. And if you pause the video here, I will continue in the next video because we're about